morning, everyone. If I could leave you with one big idea today, after the end of this presentation, it would be how valuable visualizations are for us to consume the vast amount of information that is available in our days. And not only just consume this information, but also realize trends and patterns and even find correlations between different data sets, which otherwise would be much harder or even impossible to find. Obviously, visualizations have been part of man's history since ever, and being in France, it's fair to mention the Chauvet cave. Is anyone familiar with Chauvet cave? Okay. Did you get anything? Okay. So nobody knows about Cave Chauvet? So just a few, okay, my French accent is not that good. So it's just a few kilometers from Paris, and it's where 35,000 years ago, man created what is by far the oldest paintings ever discovered. Be it either for utility or decoration or simply just a form of personal expression. Hundreds of paintings were created there, depicting more than 13 different species of animals, some of which are already extinct, and using elaborate hand-painting techniques and the cutting-edge tools they had back then, which was red ochre and animal fat. Now I know this red ochre and animal fat might remind you something you had at a bad restaurant, but it's what they had back then. And moving fast forward to our time, visualizations are more important. And the tools we have now, the web technologies we have now are very powerful in order to both create and distribute these visualizations. Technologies like HTML5 and the APIs that it exposes to JavaScript, CSS3, WebGL are very powerful tools in the hands of designers, developers, and even artists in order to display quantitative information or qualitative data, or even just build the next Mona Lisa. Really powerful tools in order to deliver a strong and clear message to the users, because it's all about delivering a strong and clear message. And an example of that I found in my airplane when I was flying in here was these safety instructions they have on the airplanes. How many of you have ever bothered to see them? Okay, not many. Actually, this is a really nice example of using visualizations to deliver a message. You might not be speaking English or even coming from a completely different culture, but these things should make sense to you. And all the information that is on this page is really condensed. And it's pretty much everything you need to know while flying on the airplane. There is actually one piece of information on this leaflet that is not available as a visualization. Would anyone want to guess what that information is? No, it's actually, I think this is like pretty much, you said about the evacuation. No, it's pretty much everything is about evacuation. It's actually a message that says, please do not remove this card from the aircraft, which obviously, I actually didn't read it when I got it from the airplane. Lie. Anyway, moving forward, how many of you know of GitHub or ever used it? Okay, most of you. For the rest of you, GitHub is like Facebook for developers. You can basically post your code. You can follow around other people. You can send them updates. It's a really, really nice service. And the one page that GitHub has is this one, which shows the repositories that are most popular forked. Forking is basically you get a copy of a repository and you can do changes. You can use it however you like. And you can even send these changes upstream and the main repository can adopt them or ignore them. And this page shows the projects that are more forked. This is a really nice way to see which technologies are popular and which new stuff come around. And you can find this information from just by looking at this page, even before these projects get mentioned on popular media. Now, the problem with this page is everything is in text and numbers, and it's pretty much to understand how much popular a project is, or see other patterns. So I did a little of screen scraping because there was no API to get this information. I used Python and the library called Beautiful Soup. And I built a visualization like this. This is a map. Basically, the bigger the box, the more forks it has. And different colors are different platforms. So the dark blue color is JavaScript. The light blue is Ruby. The dark orange one is PHP, and so forth. And by looking at this, you can draw many conclusions that were not very obvious in the original page. For example, most of GitHub is about JavaScript and Ruby. There's also a lot of interest in PHP, Bootstrap, and Homebrew, and Rails are pretty huge compared to everything else. Also, apparently, PHP, for some reason, is still very popular. But besides the page with the most forked repositories, there is also a page about the most followed repositories. In GitHub, you can follow a repository and see any changes that might be happening, similarly as you would follow a person on Facebook. And this shows a completely, not a completely different story, but shows some interesting things. Like, for example, more than half of the most watched repositories are JavaScript. Rails is still big, Ruby is still big, but much smaller, and PHP is just this small part up here, which for me tells that although many people are forking PHP repositories because they have to do some work with PHP, many popular frameworks and libraries come in PHP. Not that many people want to follow this project to see the updates because the PHP ecosystem is not that popular anymore. And I'm glad I'm not on a PHP conference saying this. So let's sum up why visualizations matter. It's an easy way to understand the relations between things, realize patterns, make sense of quantitative data. Nobody really understands what $1 billion is. That's why, for example, on newspapers, whenever they're talking about budgets and deficits and stuff like that, it's good when they use visualizations because big numbers mean nothing to people. You can also discover correlations between different data sets, and you can make boring data more engaging to simple people. And finally, you can maximize the value you are getting from the short attention span that a typical user has on your page. So in this presentation, we're going to talk about both the underlining technologies you can use to build these kinds of visualizations and some of the frameworks that will make your life easier. And to start off, we're going to talk about the technology that most people love to hate. Besides JavaScript, would anyone want to guess what that technology would be? Okay, web technology that people love to hate. Yes, CSS, which is still like the best way to do styling compared to any other way that they are doing styling. With all the problems that CSS has, it's still 10 times better than doing styling with classes and code. Now, CSS is a huge set of specifications. We would probably need like a full conference to talk about all of them. So we're just going to talk about a few of them that really make sense in the context of visualizations. So we're not going to talk about fonts and grids and stuff like that. So a huge thing for CSS is CSS3 is backgrounds and borders. You can do amazing stuff with backgrounds and borders. You can even have backgrounds on borders themselves. You can have shades. You can manipulate them. You can move them. You can have rounded corners. And if you have rectangular things and you put rounded corners of them, you can even end up with circles and aggregate those and build amazing stuff as we're going to see moving forward. Animations. These are keyframe-based animations where you set up your keyframes and you can have some CSS properties changing according to these keyframes. You can have transitions. Again, you change the CSS attributes upon some timeline. And you can have transforms. You can manipulate stuff either on 2D or on 3D. So this is an example of, on one side, on the left side, doing some simple animation using CSS3, and on the right side, doing some animation with JavaScript. I'm using jQuery here. Is anyone not familiar with jQuery? Great, everybody knows jQuery. So basically what we're doing here for CSS3, we're just setting up a transition that will take 2 seconds to happen. And when we click on that stuff, the left margin changes, which basically means that that box just moves. And here we're doing the same thing with using the animate function from jQuery. Besides looking better, the CSS3 code, one huge advantage you're getting using CSS3 is they can be potentially GPU accelerated. How many of you know what GPUs are or have some understanding why they matter? Okay, not that many. You can think of your GPU as like a second processor that you have on your laptop or on your mobile device. And GPUs are really good at doing stuff with graphics. They perform much better, and they also consume much less energy, usually. So if you have things like transitions, 3D transforms, canvas drawing, and WebGL, all these things can be GPU accelerated, and they can move much faster, not consume CPU, and not take a toll on your battery if you're on a mobile device. But again, maybe some of these things seem pretty crude to you. I mean, what can you do with backgrounds and borders and animations? Well, actually, some people are doing amazing visualizations. And here is a project I really like. So basically, these are the icons from iOS. And all these things have been created with CSS3. Nothing is images, and I can prove it to you. I can inspect. So here's it's just a div for the voice memo thing, and you have the mic, and you have the holes, and actually you have the holes in different rows. And every hole is just a div with the borders being round, so it's actually like a circle. And all these amazing things are just done with transformations and with moving things around. So pretty quickly, for a nice effect, this effect is you just have divs that you just move around. And all these things are, these techniques are called CSS3 pure design. And you can build pretty much amazing things. I know people that are building graphs with like dynamic graph components with this technology. So, moving forward, probably the most important technology for doing visualizations on the web is SVG, Scalable Vector Graphics. Now this specification goes back, I think, to 1998. At that point, there were 2 different groups of companies. One was Microsoft, Visio Corporation, and Macromedia, and they were pushing for VML, the vector markup language, which is still available on Internet Explorer, and a group of companies led by Sun, IBM, maybe Netscape, and also Adobe, which, by the way, acquired Macromedia from the first group. And they were pushing for a different spec called PGML. And the W3C came, it pretty much combined the two specs, and we got SVG. SVG is an XML format for doing 2D vector graphics on the web. Most browsers support it these days, although you have a varying support, so you really have to be careful of which features you use. You can build static drawings, you can have interactive stuff, and you can even have pretty cool animations with SVG. Something that not that many people know is that Google indexes SVG file. So if you have like a huge SVG-based animation with content, Google will index the content there, and it will show up on a Google search, which is really cool. And you can have things like transformations, really cool filters, alpha masks, templates, clipping paths, and interactivity. By the way, how many are familiar with what clipping paths are? So basically, you can draw something with SVG. You can draw a path maybe around it and say, hey, whatever is outside of that path, ignore it. So you can do like a nice star, maybe draw a circle, and it will cut off the edges of the star. So let's see a quick demo of how SVG looks like. So this is built with SVG. It's not an image, and because it's vector and not bitmaps, I can do this, and it will still look good. So some people are actually using SVG for building, their templates and their buttons and small images for responsive design, because it scales so nicely in different resolutions, and you don't have to download different files. And if we like to see how this look like, so basically it's just just a piece of just an SVG fragment. Here we do all the definitions. We define a gradient, which we'll use later on, and then we define the path that the text flows on. And then we set up the circle and the text that flows on this path. So we talked about vectors. Let's talk about bitmaps now. Canvas. It's an API that came out with HTML5. It basically allows you to render 2D shapes and images. It's really, really low-level API, and it has a procedural feel to it compared to SVG, which was markup. It basically gives you a set of JavaScript drawing functions that seem similar to other popular 2D drawing APIs. And a funny thing is how you can achieve animation with Canvas. You are basically you're setting up a timer, and you keep redrawing everything from scratch, which is basically how classic cinematography would work. But you're doing it really fast, so it looks like a smooth animation. You get basic lines and strokes with Canvas, paths. You can do really fine-grained pixel-based manipulation, because what you're actually doing is just drawing pixels. You can scale, rotate stuff, transform them. You can get a PNG representation of what you drew as a data URI. I know a couple of applications, online drawing applications, where they use this technique. So whatever you draw on their Canvas page, you can actually download it as a PNG image without hitting the server. You can embed images, obviously, and you can have all sorts of cool stuff like shadows, gradients, and alpha transparency. So let's compare the Canvas and the SVG API. First of all, as we said, Canvas is bitmap, and SVG is vectors. Canvas has a procedural feel, because basically you are just writing JavaScript, whereas SVG is declarative, it's markup. Canvas, if you're building a Canvas application, only the Canvas element is accessible through the DOM. Everything else, you're just building it with JavaScript and it's not available as a DOM element. Whereas SVG is just a part of your DOM tree. You can manipulate everything you want any way you want it. Canvas, it's basically script. SVG is inline markup, but of course you can have JavaScript to manipulate it. Now, many people think that Canvas is more developer-friendly because you're just writing code, whereas SVG is more designer-friendly. One reason for that is that many designer tools can export or manipulate SVG files, tools like Illustrator, Inkscape. Also, Canvas, since you are just drawing pixels, it's much more performant than SVG. And actually, if you're building any sort of big SVG application, after a point, it will get really slow on any kind of machine that you are running it. Now, one reason for this is that pretty much the SVG implementation, at least on WebKit, I think for the last few years, is like a one-man show, so it hasn't been evolving that much. And finally, how you achieve animation for Canvas. You just redraw every single pixel using timers or events, whereas in SVG you have true animation. You can say, take this thing from here and animate it to here, and it will happen. And here is how the two technologies different in code. Here we have Canvas, which is just JavaScript. We begin to create, both codes will create a circle on your screen and paint it. Here it is done using the arc function. This is a really kinky way to draw a circle. You have to draw mathpy twice. There is no direct way to draw a circle. And it's just plain JavaScript, whereas here you just have the circle element and some attributes, and you're done. So let's see how a Canvas demo would look like. Whoops. So basically, this is like the standard Canvas demo they give you, but in the center you have like the sun, and then you have the earth moving around. I tried to spice it up a little bit. So here you have something in the middle, you have a path which is painted, and then an element that goes around in that path. And if we see the code that builds this, we basically have an event listener that waits that everything is loaded. We set up some things in it, like the frame rate, how fast this will go. 30 frames per second is quite fast. And then we set an interval to run at that frame rate, which executes the draw function, which creates the rectangles, puts in the images, and every time it rotates the logo that goes around. And every time it redraws everything from scratch. There are some details we could talk about here that maybe go beyond the context of this presentation, like how Canvas has a stack of contexts, so you can put information in the context and then later on retrieve it. But this is like the basic idea how you can use Canvas for animations. And if you want to look at something really cool that has been built with Canvas, you can go to this URL. Mozilla has built this really awesome game called Browser Quest. Now, how many of you know of this game? Okay, the rest of you should definitely check it out. When it went out, it scaled massively. You had like thousands of people on this level playing it. And at the break, I can tell you a few hacks where you can play with people. So we talked about vectors, and we talked about bitmaps. We'll also briefly talk about 3D. Now, WebGL is a very complex subject. We're just going to briefly go over it. It's basically a JavaScript API for doing 3D graphics. It's based on OpenGL. And basically, the way it works is you have some JavaScript control code, which is a very small, a tiny percentage of your application. And then the rest of the application is built with shader code, which runs on your GPU. So it's really, really fast way to do 3D stuff. In order to do that, again, you will use Canvas, but you will initiate a 3D context instead of the 2D context we saw earlier. As I said, you have access to 3D hardware. The shader code runs on 3D hardware. And you have lots of third-party libraries. Now, the reason you need third-party libraries is because this is a really low-level API, and in order to do anything meaningful, you will need things like scene graphs and libraries to handle light and shades and all these cool things you would need to use in a 3D application. So this is a really cool demo of what WebGL can do, besides taking my CPU to 100%. I think this is the city of Oslo, and these are construction projects that the city has been working on since 2005. I think the orange ones are planning phases, the dark blue ones are construction phases, and there are some other phases, and you can see how this has evolved during the time. And I mean, if you were from Oslo, you could make more sense of this. The size of the planning project. So you will see, for example, that you have some huge planning phase. Maybe the government changed, or it was like right before elections. I mean, things like that happen even in Norway. And then usually, a big planning phase is followed by a big construction phase. I mean, watching something like that, you can realize trends and patterns, which otherwise, just by looking at numbers and text, it wouldn't be possible. So this pretty much concludes the first part about the underlining technologies, and now we're going to go over a few frameworks that will make your life easier. Quick poll, does anyone know which Grand Master from Renaissance built the School of Athens, painted the School of Athens? Okay, it was Raphael. And the framework we're going to talk about is Raphael. Raphael is an amazing library for doing JavaScript vector graphics. Basically, it uses SVG, it's like an abstraction over SVG. In browsers that don't support SVG, you will get VML fallback. This is really important. It means that you can build amazing vector stuff on your, test it on your Chrome and be sure that they will even work for Internet Explorer 6 in the form of VML. You can get things like shapes and paths, gradients, transformations, animations, and really cool events. And one more thing that you get from Raphael is that it doesn't implement SVG features that are not really available across different platforms, across different browsers. So it's really helpful in order to build cross-platform visualizations. So here we can compare the SVG implementation of a circle with a Raphael implementation of a circle. Again, as you see, Raphael is just a JavaScript API. You have the circle function, and you can add the attributes on it. Actually, I'm going to show you a case study at the end that uses Raphael pretty heavily. Now, moving forward, after Raphael, a really nice library is Processing.js. Processing.js is a port of the processing visual programming language, which is based on Java, but uses a much simpler syntax. So if you are coming from C or C++ or even .NET, this will seem very familiar to you. It has a lightweight IDE, which is based in Java. We're going to actually see how you can use it. You can build stuff and quickly see how they work before you even deploy them on the browser. You can combine processing and JavaScript in your projects. You can access DOM from within processing. And it has 3 different programming modes. Three different modes for programming. You can do basic stuff like static images. You can have the continuous mode, which basically continuously runs a loop and draws something on the script. Usually, you want to use the continuous mode. And you have the Java mode, where everything is based on an applet. Not many people do this. Now, for running, you can write pure JavaScript and use the JavaScript API, or you can import your processing code from within JavaScript, or compile your processing code to JavaScript. And for rendering, you can render your stuff in 2D, 3D. Now, if you're not running in a browser, you can also render PDF. PDFs don't run natively in the browsers, but I know that the good guys at Mozilla are fixing this. So let's see how you would go about building something in processing. This file contains processing code. PD is the extension for this code. And this is the processing environment. Basically, at the beginning, you set up the number of frames. We're going to do an animation that quickly changes some frames in order to create the illusion of animation. We set up an array for the images, and then you have the setup function, which the most important thing to notice here is we set up the frame rate. This is 30 frames per second. Again, pretty smooth animation for the web. And since this will run in continuous mode, it will basically use the frame rate we defined in order to execute the draw function, which basically changes the image we're going to see. the really cool thing about this idea is before we even think of deploying this code, we can actually test it and see how it would look on a page. And if we wanted to import this specific code inside the web page, it would look something like literally just these two lines. We just import the processing library, and then we use a data attribute, which points to the processing code. And actually, if we no, it won't. And you see exactly the same application inside your browser. Some people have been building pretty cool stuff with processing. I urge you to visit their site. They have an amazing gallery. One application I really like is this one. It basically searches Twitter for a specific string. In this demo, the string is pizza, and it actually displays the tweets that are going out with this keyword according to language. So, you have many, probably North Americans talking about pizza. Italians are doing good. I think this is India, which is surprising. And you can actually click on one of those and see what the tweet was all about. And here is one more visualization done with processing. It will basically show us how the privacy model of Facebook has been growing since 2006, 2007. I mean, many people are complaining that Facebook has been opening up its default permissions as time goes by. So, okay. So, the slices are different applications of Facebook, photos, wall posts, networks, and the sectors are different parts of your network, friends, your network, all Facebook users, and entire internet. This is how the default privacy permissions were in 2005, and you can easily see that as time went by, the default privacy settings have been opening up. So moving forward, we're going to see D3.js, which is probably my favorite library for doing visualizations on the web. D3 means data-driven documents. It's a very different way to do visualizations. It doesn't have that procedural feel we had for Raphael or for the Canvas API. The basic idea for D3 is to map data to DOM and then do data-driven transformations on them. We're going to see exactly what this means in code. D3 doesn't directly bother with how you do the graphical representations. And I have a little star there because this is like almost the truth. It does provide some facilities, but basically you can use D3 and basically use your things like SVG or Canvas or CSS to actually build the visualization. D3 gives you really cool layouts that you can use out of the box. I cannot stress how cool these layouts are. You get things with animations, with gravity, with automatically centering things in the middle of the screen, with springs, with collision detection. Has any one of you ever tried to program collision detection? And you look sad. Okay. You can actually, if you go to their site, you can actually read the papers that they were based on. Amazing work. And you will see D3 being used extensively in the New York Times. I actually think that one of the guys behind D3 is actually working at the New York Times. And things you get with D3 out of the box is W3 selectors. If your browser doesn't support the selectors API, you get fallback to Sizzle. Sizzle is the selector engine that many libraries are using. For example, jQuery uses Sizzle. You get dynamic properties, you get native transitions, you get all sorts of cool plugins. And as I said at the beginning, for the visualization part, you can still use CSS3 and SVG and any other technologies you like. So let's see how a D3 file looks like. So here's a very simple graph, which a simple bar chart. And if we see the code behind this, we basically set some styles for the various bars. We include the D3 library. Here is our data. This is just an array. This could be data we're getting from Ajax or from all sorts of places. Here we use the selector API to select the body element and append a div which will hold our chart. And then basically we are mapping the data to divs that we are building at that time, and we are calculating the style depending on how, on the number that was in the data array. And this looks like in the DOM tree, it's a chart, and then you get the divs, and the size is 10 times the data. Here we're using plain divs. You could be using funky CSS3, pure design. You could be using SVG. You could be using anything you like. The magic happens by binding the data. And if you want to see what this technology can build, it can build amazing visualizations, most of which are interactive. And I'm just going to show you, this one is one of my favorites. It's on New York Times. Even this effect of bringing everything in the middle of the screen and beautiful. And you can, as we said earlier, 472 billion as a number doesn't mean anything, but if you see it in a visualization, you can understand it and compare it and see trends and all things. And here, actually, we're not going to do this now because it's pretty big, but you can actually see the code, and you can actually see how they. No, maybe let's not do. You can actually see the code and understand how they actually built this thing. Now, the last library we're going to talk about is Fabric.js. Now, Fabric, again, has a completely different way of working compared to Raphael or D3. Basically, it defines an object model on top of canvas. This means that you can define classes, create objects, clone objects, iterate over objects, initialize them, and so forth. You can have simple shapes and paths, scale, move them, rotate them. You can dynamically manipulate text. You can have really cool filters for images. You can get from SVG to Canvas. And you can even serialize Canvas into JSON strings, which is, again, a cool way to draw something on Canvas and then download it on your machine without hitting the server. So I'm going to skip over the Fabric.js demo because we have only a few minutes. I'm just going to go, I can show you this comparison. On the top, we have the Fabric.js API, how you would draw a rectangle, and the same thing with Canvas. If you notice, here the example is very small, so it might not be very obvious, but the Fabric.js code is much cleaner and compact and easy to read, write, and maintain compared to writing everything from scratch on the Canvas API, especially since you don't have things like classes in JavaScript. Not that I would like to have classes in JavaScript, that's a different thing. I will quickly show you this case study. Basically, I work for InfoQ, and we've been building this research tool, which will answer questions about trends in our industry. So instead of going to a company like Gartner or Forrester and getting some report that might be biased, or you have people from the community actually saying their opinion, and we are aggregating these results. So this is like a dot voting widget we have on one of those research items. I think this is about what features you would like to see in Java 8. And people can go in, they have 8 dots, and they can put them in. And then you can use visualizations to show these results. So for example, a funny thing is that people have not been putting in more features into Java because they are claiming that everybody wants it to be backwards compatible. At least Oracle says that, and Sun was saying that before that. But you actually see most users don't really care about Java being backwards compatibility. They want other stuff. And this is a much better way of seeing the data than just seeing the plain numbers. Here's a widget so people can actually vote on stuff. This is about, I think, agile practices. So people drag this stuff and put them on this interactive radar, depending of if they think this agile practice is useful or if they're going to adopt it. And then you can use, this is built with Raphael. You can see where things are, and the bigger the circle, the more votes they're in. So actually, this is from a different poll about cross-platform frameworks, cross-platform mobile frameworks, and you can see PhoneGap is really popular, and jQuery mobile, and whereas Mossing is not that popular. And because the average counts, but you would also like to see how the votes are distributed, this is a different visualization called heatmap, which shows exactly how people are voting. So here you can see that pretty much everybody voted for this thing, which is continuous integration. Pretty much everybody thought it was pretty popular. Whereas here, although the average is still there, this is pair programming, you can see that opinions are scattered across the radar, so you can see that the community doesn't have a strong consensus about this. So, I hope you enjoyed the presentation and go out and build amazing visualizations yourselves. We have, We have a few minutes if you want to ask any questions. Yes? I'm pretty sure that it works down to Internet Explorer 6. Of course, if you're going to use, for example, SVG to display stuff with that, SVG will break the experience in Internet Explorer 6. But I think by itself, yeah, actually, we are using D3 in some places in our project, and it worked pretty nicely up to. I know that many frameworks recently have stepped away from supporting Internet Explorer 7 and many big services, and I think a few days ago, Google stopped support for Internet Explorer 7, which is pretty huge. So maybe you used some newer version that stopped compatible. But as far as I've used it, it worked nicely. And since we are just before lunch or almost before lunch, this is a really nice visualization. It's a project called Data Cuisine, and a bunch of people gathered and tried to make visualizations with food. So this is the distribution of immigrants in Norway, I think. So smoked salmon is which country? Sweden. Rice is China. And I don't remember the rest. So when you're having your lunch, you can still start playing with visualizations yourself. Yeah, it's not lunchtime. Thank you.